Okay, welcome to the final part of this problem. So in the last couple of videos, we went over the problem statement and the algorithm. And in this video, we are going to go into our IDE and start writing Python code to solve this problem. So very quickly, we have a beam AB that has a bunch of forces acting downward. And the idea of this problem, or what we need to do, is we need to find a resultant force of all of these F forces and figure out where it's acting from point A on this beam. So in the algorithm part, the very first step was to figure out the force lists and the distances lists. So I'm going to go ahead and do step one here, which is define our input. And so remember, we're going to create two variables here. One is going to be a list of forces, and the other one is going to be a list of those x values, the distances. And both of these variables, these lists, can have any number of elements so long as both of these variables, both of the lists, are exactly the same size. So I'll just go ahead and plug in some random values here, just for the sake of running this problem. Okay, so I've plugged in some values here. So these forces are going to have values of -4, -5, -3.2, -9, and -1.8. And remember, the reason there are negative is because our positive y direction is facing up. So these forces are acting down, therefore they are negative. Now, these I can just say they are in newtons of, or units of newtons. And for the distances, let's just say these are meters. So I've formatted this list, so hopefully they're a little bit easy to see. So this -4 force is at a distance of 0.7 meters from the left side of the beam. And the same thing goes for all pairs of these values. Okay, awesome. So that is basically this step one, where we just figure out the inputs, which are the forces and the distances. Now, step two would be to figure out what the resultant force value is. And remember, the resultant force is just the sum of all the forces, and we were going to use this sum method. So let's go ahead and do step two, is figure out the resultant's value. And the resultant's value, I'll just assign it to some variable called resultant. And this is going to be a method called sum. And to sum, we're going to pass in our forces list. So sum takes in a iterable object, and an iterable object is just an object that you can iterate over. So because forces is a list, we can iterate through each one of these values in the list. And what the sum method is going to do is it's just going to give us the resultant. So we can sort of check that really quick and say, okay, let's print resultant to the console. And if I hit play, you can see that the resultant force is -23 newtons. Okay, awesome. So I'll go ahead and just delete that. That was just for checking. Now, the next step was a little bit more involved. We need to find the equivalent moment at A by basically summing all of the moments that all of these forces on the beam create at point A. So remember, we're taking F1 times its distance plus F2 times its distance all the way up to Fn times its distance. And in order to do that, we needed to create a tracker variable. So we had a tracker variable called MAR, and we set that equal to 0. So let's go ahead and do that first. So let's figure out, find the equivalent moment at point A, which is the left side of the beam. The very first thing we want to do is set up that MAR variable, and that will be set to 0. And of course, this is going to be Newton meters for the units, right? It's a moment. Now, the next thing we need to do is we need to iterate over every single one of these elements. Now, in Python, we can do that using a for loop. So I could say for force in forces, do something. So what this loop does is it basically iterates through each one of these force values, and it assigns each element to this force variable in the loop. So if we printed out force, not forces, but just force, then in the console over here, you'll see that we get 5 different values. And that's -4, -5, -3.2, and so on. So what this loop is doing is it's iterating through each one of these forces and then doing something with that value. In this case, we're just printing out that value. However, we need to calculate the moment and we need to update this MAR variable. And in order to calculate the moment for each one of these force values, we also need to know its respective distance from the distances list. So we need to change this for loop a tiny bit. Firstly, instead of iterating over through forces right here, what I'm going to do instead is I'm going to use a method called enumerate, and then you can type in forces there. And over here for this variable, I'm going to say I, force. Now, what this does is that instead of just iterating over the values of whatever list we give this for loop, so in this case it was just forces, because we said we want to enumerate over forces, what this is going to do is it's going to give us the index as well as the value. So instead of just giving -4, -5, -3.2, and so on, it's also going to give us the index of that particular element. So in other words, if I did, print force and then also print I, then if I run this, you'll see that I is 0 over here, and then the force is -4. And 0 means it's just at the first element. And then I have index 1, and that's -5. Index 2, that's -3.2. Remember, computers start counting at 0, not 1. Now, the reason this I variable is so important is because we need to use that index variable, and we need to pick out the respective distance that that particular force is acting from. So in other words, for each iteration of this loop, I can say that the x distance is going to be distances, our distance list, and that's going to be at I. So what this is going to do is if I is 0, then it's going to give us 0.7. If I is 1, it's going to give us 0.9. And all I'm doing is I'm just storing that variable or that value into this variable called x distance. Now, the next thing I need to do is I need to multiply that distance by this force, whatever current force we're iterating over. And remember, force times distance is moment, and so once we calculate moment, we update our MAR variable within that loop. So I can say MAR is equal to the current value of MAR plus that force times x distance. Okay, so what this is saying is that, hey, for each iteration of the loop, take whatever MAR is, in this case it starts off as 0, so this would be 0, and then add to it the moment for that first force. So it's going to take force times distance, it's going to add it to MAR, which is 0, and then reassign it to MAR. And so on the next iteration of this loop, I is going to be 1, so we're looking at this next pair right here, this -5 and 0.9. It's going to take the previous value of MAR, calculate the moment, update it, and then reassign it to MAR. Now, there is a shorthand way of doing this, and because we're using MAR to increment, I can say MAR plus equals force times distance. So it's the same exact thing, but this plus equals is just a shorthand way of saying, hey, take the previous value of MAR, add to it this force times distance, and then reassign it to MAR. Okay, so after this is done, let me print out MAR so you can sort of see what the value is after this entire for loop is done. So after we've gone through every single one of these elements, calculated the moment, and then assigned it to MAR, MAR is going to have a final value of, look at that, -37.12 Newton meters. Okay, awesome. So this for loop is working and we're pretty much almost done. Now, the last couple things to do was, well, if we look back at our algorithm, is, well, we set up a tracking variable, MAR, we iterated through each one of those forces, and then we added that moment to MAR, and we found a final value of MAR. Now, the next step was to find the x distance for the resultant using R and MAR. So that was pretty simple. We just take MAR divided by our resultant value. So if we go back to our script right here, I can say find the x distance of the resultant force. Okay, so our x distance, I'll just label as x, that is equal to MAR divided by the resultant value. And if I quickly print this out just to check and I run, you can see that our x value is about 1.614 meters. So that just means that this resultant force, if the resultant force is somewhere over here, that distance from point A to that resultant force is this 1.61 meters. So, okay, awesome. That seems to be working. Now the last step is just to print out those results using a formatted string. Now, a formatted string is just a fancy string that we can inject these variables with, and I'll just do this next section. So format the answer and print it out. Now this is going to be print, and to do formatted strings, we start off with F and then single quotes, and then I can say something like the resultant is this resultant value that we found up here, and that is the resultant is resultant newtons that acts at a distance of x meters from A. So remember, resultant is this resultant right here. X is just this distance of that resultant force, and I just plugged it into a string. Now I'm going to run this, but you'll see that when I run it, things are a little weird. The resultant is negative 23.0 newtons, and that acts at a distance of 1.6139130 blah 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 meters from A. What would be nice is if we could just round down some of these values, and so we don't have this super precise distance, right? We can just round that down to, let's say, 2 significant figures, and that should be plenty. So right before this formatted string step, I'll say let's round our answers. Now in this section, what I want to do is I want to say x is equal to round, and that is going to be x and 2. Okay, so what does this mean? Well, this round function takes in 2 arguments. It takes in the value that we want to round, and then it takes in another value, which is the number of decimal places. So what this is saying is I want to round x, which is our distance, to just 2 decimal places, and then assign that value to x. And then I can do the same thing for resultant. So resultant is round resultant to do decimal places. Now, if you look at the console, you can see that the resultant is already pretty nicely formatted, negative 23.0, and that's because in our forces array, or our list, we just had whole numbers or just decimal numbers that only had 1 decimal place. If we had forces that were a lot more precise, then we could see our resultant force going up in significant figures, and this just ensures that it will always stay to just 2 decimal places. So that looks pretty good. Let's go ahead and rerun this, and you'll see that this string right here now has more appropriately formatted values. So if I hit run, you can see, yep, the resultant is negative 23, and it acts at a distance of 1.61 meters from A. Okay, awesome work.